Okay, in this video we are doing Calc AB problem set 82. The problems and playlist are in the description below, and let's do it. We want to evaluate the integral of x to the fourth over 8 dx. This is kind of a straightforward problem. I'm surprised that I wrote it, to be honest. I'm going to pull out the 1/8. There's no need to do that. You could just leave it in. You could definitely do this in your head. Pulling out the 1/8, I'm going to reverse the power rule, get 1/8 times 1/5 x to the fifth plus c, and then I'm going to multiply those and get 1 over 40 x to the fifth plus c. I don't know how this made it into the problem set, but whatever. It's there, it's done. Next problem. All right, we want to evaluate the limit as x approaches 0, e to the 5x minus 1 over sine of 3x. So the first thing you should always try to do is just substitute in. I will say the vast majority of limits, when you do that, you'll just get 0 over 0. But you never know. So e to the 0 is 1, 1 minus 1 is 0, and then the sine of 0 is 0. So we do get 0 both times. So we're going to use L'Hopital's rule. We're going to do it the right way so that on a free response question we would get all the points. So here goes. We want to clearly identify that the limit of the top and the bottom are both 0. So I will say the limit as x approaches 0 of e to the 5x minus 1 equals the limit as x approaches 0 of sine of 3x equals 0. Therefore, by L'Hopital's rule, the original limit is going to be equal to the limit as x approaches 0 of the derivative of the top, which is 5e to the 5x, don't forget the chain rule, over the derivative of the bottom, which is going to be 3 cosine of 3x. Again, do not forget the chain rule. The chain rule really gives you the answer here. Otherwise, you would think the answer is 1, and you would be wrong. So when we substitute now, e to the 0 is 1, so we get 5 on the top. Cosine of 0 is 1 as well. So we get 5 divided by 3, and that is our answer. So hopefully you're feeling pretty good about L'Hopital's rule at this point. It's really just the quality of your work that you have to make sure is like top notch, because like the concept itself is pretty simple, pretty straightforward to apply. But they're pretty picky about the way they grade them. All right, next up. Use the substitution u equals square root of x to rewrite the integral below in terms of u. This is a weird question. This is like a multiple choice question usually, but we're just going to do it, right? There aren't options. So I'm going to say obviously that u is the square root of x. I mean, that's given. So before I try to find dx, I do not want u to be, I don't want x rather to be inside of a function, so I'm going to square both sides. So u squared is equal to x. So now 2u du is dx. So when you substitute for dx, do not forget that it is 2 times u du. I tend to forget that. That's why I'm saying that very slowly. All right, now I need to convert the bounds. So forgetting to substitute correctly for dx and forgetting to convert the bounds are the two most common issues that are run into here. And on a multiple choice thing, they'll definitely give you the option to forget those. So be on the lookout for it. All right, if x is 25, then u is the square root of 25, which is 5. And if x is 9, then u is the square root of 9, which is 3. So we're ready to just substitute. So I'm just going to kind of go for it. The bounds are 3 and 5. And then we'll get e to the 2u. In our denominator, that square root of x becomes u. Now I need to substitute for dx, which is going to give me a 2 times u times du. I'm going to pull the 2 out, so 2 u du. Then if you look at this, the u's are going to cancel. So we get 2, the integral from 3 to 5, e to the 2u du. That's the answer to the problem. We don't actually have to evaluate it, but we definitely could if we needed to at this point. We just don't need to. So I'm not going to, but if you're looking for not much of a challenge, but a little bit of a challenge, like go ahead and evaluate that. All right, next up. Evaluate the integral from, nope, not a definite integral, just evaluate x to the fourth minus 3x squared plus 4 all over x plus 3. I'm about to do a commercial for synthetic division because I'm going to do long division on this, and it's terrible. So we set it up. You should do synthetic. I highly recommend it, right? It would just be -3, and then you go 1, 0, -3, 0, 4. You'd be done in like 15 seconds. Instead, I'm going to do this. I need to multiply x by x cubed so that it'll balance out with x to the fourth. And then I do this, right? So I multiply x plus 3 by x cubed. That gives me x to the fourth plus 3x cubed. I'm going to subtract it. That leaves me with -3x cubed. Bring down the -3x. Now I need to multiply x by -3x squared to balance out -3x cubed. So I'm going to do that. Now I actually multiply it. And now I'm going to subtract down. The -3x cubes cancel, and -3x squared plus 9x squared is 6x squared, and bring down 0x. I need to multiply x by 6x to get 6x squared. So that's what I'm going to do. do the multiplication, subtract down, we're going to be left with negative 18x, bring down the 4. We need to multiply x by negative 18 to balance out negative 18x. So we do it, do the multiplication, subtract down, we're left with 58. 58 is a lower degree than x, so we're done. So really, I'm going to put the remainder up here. The actual problem that we're trying to do, the original problem is equivalent to this problem. Integrate the quotient that we got. This is a straightforward integral because we're just going to reverse the power rule 4 times, depending on how you think about negative 18. Maybe you look at negative 18, you're just like, that integrates to negative 18x. I don't know. You're still reversing the power rule. And then we'll get a natural log, right? 58 over x plus 3. U is equal to x plus 3. So you have 1 over u du. Integrate it. Here's our answer. I got 1/4 x to the 4th minus x cubed plus 3x squared minus 18x plus 58 natural log absolute value of x plus 3 plus c. So of all the things you could do that, the place where I could imagine you going wrong there is forgetting the absolute value on x plus 3 or just getting the division wrong. It's really annoying. I would have done synthetic if I could go back in time and do it again, but I didn't. So there you go. Synthetic's always better for linear factors. Quadratic factors, you have no choice. You're going to have to do long division, but synthetic is going to work on your linear factors. Definitely recommended. Next up. Evaluate the integral from negative 5 to 0, f of x dx, where f of x is the absolute value of x plus 3 over x plus 3. I feel like we haven't seen this function in a while, but I could be wrong about that. I'm going to graph it and just base my answer on the graph, right? So I know that this is the graph of the absolute value of x over x just shifted 3 units to the left. So there's that. And then the absolute value of x over x is 1 to the right of 0 and negative 1 to the left, but we shifted 3 to the left, so it's going to be 1 to the right of negative 3 and negative 1 to the left of negative 3. We have this. Now, all we have to do is find 2 rectangles and add them up, right? Because we're going from negative 5 to negative 3 here. And that's a rectangle that has a base of 2 and a height of negative 1, so negative 2. And then we're going from negative 3 to 0, which has a base of 3 and a height of 1, so we get this. So the overall answer is negative 2 plus 3. So the answer is 1. I put the answer in the wrong place. I just said that the function was equal to 1. That's wrong. It's actually let me see if I don't know if I can move this. The integral is equal to 1. That should have been our answer. All right, so I think that's good review. We did limits with this function a lot previously. It comes up. This, by the way, is like a super weird integral because it has a discontinuity right in the middle of it, but it's a jump discontinuity, so that's okay. An infinite discontinuity, we'd be out of luck in Calc AB. Calc BC, there's something you can do with an infinite discontinuity, but that's not required in AB. So good problem. That's the end of the problem set. Hope this was helpful, and good luck.